Well, hello again. Hopefully everybody's doing pretty well. Today we're going to go on and learn about the second section of Chapter 0. Much of this section is review, which will take you back to Algebra 1 or even junior high, because the majority of what it deals with is lines. So you should know that if you have an equation that's written in the form y equals mx plus b, you have a line. And when you have that, the b, the number by itself, is always the y-intercept where it crosses the y-axis, and the m is the slope. So if I had something like y equals negative 4/3 x plus 5, I know if I want to graph it, I have to go up to 5 on the y-axis, and from there I count down 4 and over 3. So think for just a second, what would you do if you needed to graph this line? And of course, f of x is the same as y, so here we have f of x equals 4x minus 3. I know the y-intercept has to be at negative 3. The slope here is 4. Honestly, if I were doing this myself, I would just count up 4 and over 1, which would get me to the point 1, 1. I have an arrow pointing to that. The place I got this from, they ended up going up 12 and over 3, which is just a different way to get a slope of 4. Here's another line for you guys to think about. What would you do if you had to graph f of x equals negative 2, or y equals negative 2? Sometimes people will try and tell me that this equation has no slope. It actually does have a slope. Its slope is 0. That's because you could think about this as being y equals 0x minus 2. And there the y-intercept is negative 2, and the slope, the number by that x, would be 0. So that means I go down to negative 2, and then from there I go up 0, but across however many I want, and what I end up getting is all the points where y is negative 2. Anytime you have something where it's just a number, you always get a horizontal line, a line that goes straight across. So here's a horizontal line through negative 2. The big point they make in this section is that in real-world situations, like story problems, when you have linear functions, you have things you could model with lines, the y-intercept, that number that's just by itself, is always a starting amount. It's what happens if you don't change anything at all. And the slope tells you some sort of constant change. So we're going to look at an example to show you how that fits into things. Here's a real typical problem that can be modeled with a line. It says a salesperson earns a base salary of $200 per week and also earns a commission of $15 on every item she sells. If she earned $905 one week, how many items did she sell? So we know her base salary is $200 a week, and we get a commission of $15 for each item she sells. What they're telling you in those two parts are the y-intercept and the slope. Because again, the y-intercept is just the starting amount, and here she's going to make $200 even if she doesn't sell a thing. And the slope is a constant change. Every time she sells another item, she's going to make $15 more. So here I know the y-intercept's 200, the slope is 15, and then the question is asking me, so what's going to happen if she does earn $905? Knowing the slope and the y-intercept tells me from this equation we're going to know f of x equals 200 plus 15x, or you could say y equals 200 plus 15x. Again, she starts with $200, she's going to make $15 for each item she sells. They're telling us that she ended up earning $905, so basically we know f of x equals 905. So what I've got to do is solve 200 plus 15x equals 905. It's a real basic algebra problem. You subtract 200, divide by 15, and it turns out she would have had to sell 47 of those items she's selling to make $905. So 47's the answer. So we're going to look at these things one step at a time. And it should make sense that the first part of this basically tells you y equals 2x plus 1. That's a line with a y-intercept at 1 and a slope of 2. You go up 2 and over 1 to get to the next point. You can see that line graphed in the picture, but for our answer, we don't want the whole line. We just want the part that starts when x is 0, so like the point 0, 1, and it goes up to but doesn't include the place where x is 2. That would be the point 25. Basically, my answer here is a segment, and that's all I have for this part. The middle part would be the equation y equals 5. That's a horizontal line. It goes across the whole graph paper at 5. But again, I don't want the whole thing. I just want where we start when x is 2 and we end when x is 4. Basically starts at the point 25 and we end at the point 45. I'm going to get a little segment that just covers those points. And the last part is another line. This time 9 minus x would have a y-intercept of 9 and a slope of -1. So you'd start at 9 and go down 1 and over 1 repeatedly. Again, you can see the whole line graphed in that picture, but what I want is just the part where x is bigger than 4. So it's the right-hand side of this I want, but not the left. For my final answer, what I've got to do is put all three of those things I just talked about together. And that's what's shown in this picture, which I purposely graphed with 3 different colors so you could see what's going on. For all the places where 0 is less than or equal to x, which is less than 2, you have the red line that's over at the left side. We have a line that goes up and it starts at the point 0, 1, and then it goes up to the point 25. Once I get to that point 25, I go to the second equation because x is going to be greater than or equal to 2. And now I have y equals 5. I just have a horizontal line that goes straight across. That's the blue line in the middle. This one, if you look carefully, you'll notice I put the endpoints in blue also, and that's because I do have or equal to at both of the ends of this line. So both of those endpoints are going to be part of this line. Finally, the green line is 9 minus x, and that I put in for everything that's from 4 onward. And so we have all 3 of these parts that go in there, but I need to make sure that I just show the part of each line that's going to be covered in this answer. That kind of graph is exactly what we were looking at in the last video when we looked at the sort of checks that people will get from the coronavirus stimulus. What we were looking at last time was what happens with single filers, single taxpayers, and we figured out that the function was 1200 if x was less than or equal to 75,000, 1200 minus 0.5 quantity x minus 75,000 for between 75 and 100,000, and 0 for everything from 100,000 up. And that is what the darker graph in this picture is showing. up through 75,000. It's a solid horizontal line that goes across at 1200. Then we've got a diagonal line that goes down. That's showing you the middle function. And once you get to 100,000, it levels off again at 0. So again, there's 3 parts to it, and they're showing what each part is. Section 02 actually has a whole bunch of kind of strangely unrelated stuff. While most of it deals with lines and piecewise functions, there are a couple of things that are there to start you thinking about stuff that's coming later. One of those involves the quadratic formula. And you probably remember from trig class that formula that says negative b plus or minus square root of b squared minus 4ac all over 2a. And no, you don't need to memorize it. All they're going to ask you in this section is to look at a function and figure out what's a, what's b, and what's c. And so I've got one here, 7 plus 2/3 x squared minus 5x. You need to look at that and figure out, if you were actually solving this with the quadratic formula, what would you put in for a, b, and c? And the important thing is that they're not necessarily written in the right order when they give you problems like this. A is always the number by x squared, the coefficient on x squared, and here that's 2/3. B is always the linear coefficient, the number by x. That would be -5 in here, and the negative is important in the answer. And C is always the constant, which is going to end up being 7. So really the trick on these is just to sort out which one comes first if you wrote them in standard form. And again, A is always your quadratic term, B is the linear one, and C is the constant. And the final thing that comes up in this section deals with exponents and absolute value. Again, I told you there's a bunch of kind of unrelated stuff that all comes up in this same section. I have a problem here that if you can do this one, you can do all the stuff they're going to ask you about with this topic. It asks you to figure out what's the absolute value of 5 to the -2 power. So I'm going to have you think about that for a second, and then we're going to talk about what's up with it. So before I go on to the screen that shows you the answers, I want to point out a couple of things. First of all, absolute value acts just like parentheses. So you always do what's inside the absolute value before you worry about going outside. The second thing, and it's really the most important, is that negative exponents mean you do the reciprocal and make it positive. In thinking through those two things, the first thing I did is I figured out that 5 to the -2 power is the exact same thing as 1 over 5 squared. Again, you flip it over and make the exponent positive. Then I think, well, 5 squared I know is 1/25. And so what this problem's really asking me is what's the absolute value of 1/25. Absolute value, of course, just means how far it is from 0. If it was negative, I'd make it positive, but I don't have to. So it's just 1/25 for the answer. You could put 0.04 if you wanted as well, but 1/25 would be the main answer to that. So kind of a whole bunch of unrelated stuff that comes up in this section. Really, for what comes later, piecewise functions are probably the most important thing, and you do want to know the basics of how lines work. You also will have that quick review of quadratic formula, and you do want to make sure that you understand absolute value and negative exponents. So you'll have a couple of worksheets to practice that, and then you'll want to take a look at this week's quiz. Point out to you before I quit here that there were a couple of people that didn't take last week's quiz on time, and what I've done is I ended up creating an alternate version of that that has some different problems, so it's not just the same answers. And if you are taking the quiz late, you do need to take that version of it. That's all that's posted on the web page now. And you will get credit, but it does still need to happen because that does count towards your grade. That is important. If you already took the last week's quiz, you don't need to do that again. You've already got your credit for it. And this one will be due on Friday the 3rd. You do want to make sure that you get this week's stuff done as well. So, again, keep healthy and safe. Have a good week, and we will see you guys.